This video is from MGF 1107, section 4.2, when Euler paths and circuits are discussed. In this problem, we have a layout of a city with different land masses and bridges as shown in the diagram and up in the upper right hand corner. And it has two questions for us to ask. The first one, is it possible for city residents to walk across all of the bridges without crossing the same bridge twice? And one way you could do this is you could just leave the diagram as it is and start at one bank or island and try to go across all the bridges exactly one time. Another thing you could do is you could sketch a graph from this with vertices and edges. And since we are talking about graph theory, that is the route we will take. So for each piece of land, we can denote that with a vertex. So there's vertex D. There's vertex B, the upper bank. Island A. And island C. And then we can draw edges between each of the pieces of land that have a bridge connecting them. So our edges will be the bridges. So from A to B, there is a bridge, so we'll make a vertex. From A to D, A down to D, there's a bridge, so there'll be a vertex connecting, there'll be an edge connecting vertex A and D. There'll be an edge, there'll be an edge between A and C. And you notice up here, there are two bridges between B and C, which means there'll be two edges between B and C. There's a bridge between C and D. And I believe that's it. You notice D and B are not connected with an edge directly because there is no long bridge from B to D. So, looks like I have all the bridges accounted for with different edges. So now when it says, is it possible for city residents to walk across all of the bridges, edges, without crossing the same bridge, edge, twice? That means we're trying to find an Euler path. Euler starts with an E and it deals with the edges of a graph. So we want to make sure we use all of the edges, bridges, exactly one time. So to do that, let me change colors real quick. Now you notice the degree of A is 3, the degree of B is 3, the degree of C is 4, and the degree of D is 2. So we know from the textbook that if we have two vertices of odd degree, like A and B, the way that we're going to come up with an Euler path, where we use all the edges exactly once, is to start at one of the odd degreed vertices, and we'll happen to end at the other one. So we're going to either have to start at A or B. So I'm going to start at A. So this can be done. So the answer to part A would be yes, it can be done, because there are exactly two odd degreed vertices. So let's start at B. Let's start at A. And let's use each edge exactly once. Remember, the edges represent the bridges. So we have three ways to go. Let's just go to, let's walk to C, then walk down to bank D, walk out to island A, walk to bank B, walk over one bridge to island C, and walk on the other bridge back to bank B. So you notice what we did is we started at A, we used all the edges, which represent bridges, exactly one time, and we ended at bank B, which was the other vertex of odd degree. They both had degree 3, which is an odd number, where D and C had an even degree because they had degree 2 and degree 4. So it could be done. And what we did is we started at A and we ended at B. So that would be this option right there, the second option. Now, we also could have started at B and ended at A, but that wasn't another option. So the only correct option is the second one there. They could start at A and end at B.